section of manufacturing process module 2. In this section, I am going to discuss about thermit welding process, friction welding process, and electron beam welding process. First of all, thermit welding process. Short form of thermit welding process is TW process. In thermit welding process, the heat required for welding is obtained from chemical reaction take place between metal oxide and metallic reducing agent. Thermit is a trade name of mixture of metal oxide, commonly iron oxide, and metallic reducing agent, commonly aluminum is using as metallic reducing agent. In thermit mixture, which consists 5 part of aluminum and 8 part of iron oxide. So during thermit welding process, the heat required for welding is obtained from chemical reaction between iron oxide and aluminum. Iron oxide is metal oxide and aluminum is metallic reducing agent. See, during the thermit welding process, the thermit mixture is ignited using a powdered magnesium or a mixture of aluminum and barium peroxide. Powdered magnesium or a mixture of aluminum and barium peroxide, which is used to ignite the thermit mixture. And thermit ignition powder can be also ignited with a spark from flint gun or using burning magnesium ribbon. Thermit ignition powder. Thermit ignition powder means powdered magnesium or a mixture of aluminum and barium peroxide. This thermit ignition powder can be ignited with a spark from flint gun or by using burning magnesium ribbon. So during the chemical reaction, there will be tremendous amount of heat will be producing. The temperature almost 2760 degrees Celsius will be formed. The iron in the iron oxide that will be melted and formed to liquid state within 25 to 30 seconds. Iron in the iron oxide that will be melted and changed into liquid state within 25 to 30 seconds. Aluminum in the mixture combine with oxygen to form aluminum oxide, which serve as a slag and float on the top. And thermit reaction is an exothermic reaction. Exothermic reaction means which will releases heat energy. So this is the figure of thermit welding process. Thermit welding process consists thermit mixture, metal oxide and metallic reducing agent. Iron oxide is using as the metal oxide and aluminum is using as the metallic reducing agent. And this thermit mixture that is ignited by using a powder of magnesium or a mixture of aluminum or barium peroxide. And that thermit ignition mixture that will be ignited by using flint gun or burning magnesium ribbon. See, during chemical reaction taken place between metal oxide and metallic reducing agent, a tremendous heat will be produced. It will be almost near to 2760 degrees Celsius. Due to that heat, the welding will take place. So application of thermit welding process are: thermit welding is mainly used in rail welding, concrete reinforcement welding, burning up of steel mill wobbler and for electrical connections. So these are the main applications of the thermit welding process. So next one is friction welding process. Short form is FW process. Friction welding process is basically a solid state welding process. In solid state welding process, there is no liquid or molten phase is present at the interface of the metal piece to be jointed, and joining takes place by the application of heat and pressure or pressure only. So in friction welding process, friction uses friction to create heat to fuse two pieces of metals together. See, in a fusion welding process, friction is using to create heat to fuse the two pieces of metals together. This process is used mainly in butt welding of large sections, round rod, very heavy tubes and pipes. So no external heat is applied. Okay. So this process, fusion welding process, is basically a solid state welding process. There is no molten or liquid phase is present at the interface of the metal piece to be jointed. The heat required for welding is obtained from the that friction which is used to fuse the two pieces of metals together. See, what's the main application of friction welding processes, which is used to produce high quality butt weld in large circular section pipes and tubes. See, no external heat is required during this process. See, this is the figure of friction welding process. So in friction welding process, mainly used to produce high quality butt weld in large round section pipes and tubes. So these are two pieces. One piece will be remain stationary and other one is rotating. So initially the two pieces will be held together and contact each other by light pressure. So when the piece is rotating, then due to friction, the heat will be forming here, and due to that heat, the interface will be moved to plastic state. When this interface will be moved to change to plastic state, a high pressure is applying in the stationary piece and the joint will be taking place. So what is the defect of this friction welding process is an upset will be forming at the joint area. You can see this is the upset that can be later removed by grinding process. So in a friction welding process, the two pieces to be welded, one piece will be rotating and other will be remain stationary, and that will be moved together held by light pressure initially. When one piece is rotating, due to friction, the interface will be changed into plastic state due to heat from friction. When the interface will be changed to plastic state, very high pressure is acting over the stationary piece and joining will take place. So this is the working principle of a friction welding process. So what's one of the disadvantage of friction welding process is an upset will be forming at the joining area. This can be later removed by using grinding or any other process. So what's the advantage of friction welding process? Suitable process for joining dissimilar metals. Process produce a clean metal to metal welding surface. A highly skilled welder not required. A weld with less defects can be obtained. No filler rod is used. Disadvantage. The machine is costly. Less thick size cannot be welded. Soft metals and metals with low compressive strength cannot be welded. There is a chance that the metal will break during the friction welding process. Only butt joint can be done. That's an important point regarding friction welding process. Only butt joint can be formed using friction welding process. Applications are metals that can be welded by friction welding process include carbon steel, steel alloy, stainless steel, copper, aluminum and titanium. So these are the metals that can be welded using friction welding process. So that's about the friction welding process. So friction welding process is a solid state welding process. No liquid or molten phase is present at the interface of the metal piece to be jointed. Friction welding uses friction to produce heat to join the metal piece to be welded together. In friction welding process are commonly used to produce high quality butt weld in round rods, pipes and tubes. One piece will be rotating and other piece will be remain stationary. Initially, both of the edge of the piece to be held together by using light pressure. When one piece is rotating, due to friction, the interface of the metal piece to be jointed changed into plastic state. At the same time, very high pressure is acting over the stationary piece and the welding will taking place. Okay. So next one is electron beam welding process. Electron beam welding process. Short form is EBW process. See, electron beam welding process is a radiant energy welding process. In electron beam welding process, kinetic energy of electrons are used, which is used to produce heat energy required for welding process. Kinetic energy of electrons that is converted into heat energy. That heat energy is used for producing welded joint. So electron beam welding, the short form is EBW. It is basically a radiant energy welding process in which kinetic energy of the electron beams, which is used to produce heat energy required for welding process. Electron beam welding are commonly used for welding high cost material like titanium, molybdenum, tungsten as structural components. So electron beam welding process, which are mainly used for welding high costly material like titanium, molybdenum and tungsten. So electron beam welding process is an automatic welding process performed in a vacuum without shielding gas, no electrodes, filler rods, nothing will be used. So electron beam welding process, which does not using an electrode, filler rod, shielding gas, nothing. The entire welding process is taken place in a vacuum chamber. See, this is the figure of electron beam welding process. Electron beam welding process, which mainly consists an electron beam gun and a vacuum chamber. That are the main equipments in electron beam welding process. An electron beam gun and a vacuum chamber. Electron beam gun consists a tungsten filament which emits electrons, then an anode, then a cathode and a focusing coil or deflecting coil. So these are the main components in an electron gun. Electron gun consists a tungsten filament, a cathode, cathode which is negative. Sorry, here I marked as positive, but it is negative, and an anode which is positive, and a deflecting coil or focusing coil, and a vacuum chamber. So these are the main equipments in a electron beam welding process. So during the working of the electron beam welding process, the tungsten electrode that will emit electrons when tungsten filament is heated to 2000 degrees Celsius. So this is the tungsten electrode. This tungsten filament that will emit electrons when tungsten is heated to 2000 degrees Celsius. And these electrons are passing through the cathode. This is cathode actually, not anode, negative sign. So when these electrons are passing through the cathode, it will be concentrated. And this anode is positive charge. So an anode that will accelerate the electrons and passing through the anodes. Anodes will accelerate the electrons in downward direction. So when these electrons are passing through a magnetic lengths or deflecting coil, it will deflecting coils will concentrate the or focusing the electron beam to the point where we require welding operation, where heat has to be produced. So that's the purpose of the deflecting coil. Deflecting coil that will correctly point the electron beam to the workpiece where the heat has to be produced. And during the process, the kinetic energy of the electron that will be converted to heat energy when the electrons are hitting the workpiece. See, in electron beam welding process, the entire process is taking place at the vacuum. The vacuum pressure is normally 10 raised to minus 3 to 10 raised to minus 6 hectopascal. 10 raised to minus 3 to 10 raised to minus 6 hectopascal uh, vacuum pressure are commonly used. Okay, so once more, electron beam welding process is a radiant energy welding process. In electron beam welding process, kinetic energy of the electron beam are converted into electrons are converted into heat energy. That heat energy is used for welding process. Electron beam welding process, which is used for welding highly cost material like titanium, tungsten, molybdenum. The main equipments in electron beam welding process are an electron gun and a vacuum chamber. Electron beam welding process is an automatic welding process which does not consist an electrode, shielding gas, filler material, etc. So, electron gun and vacuum chamber are the main equipments in electron beam welding process. Electron gun consists a tungsten filament which will emit electrons when heated to 2000 degrees Celsius, a cathode that will concentrate the electron beam, and anode which will accelerate the electron beam to downward direction, and a focusing coil or deflecting coil which correctly position the electron beam to the over the workpiece. So during the working of electron beam welding process, the tungsten filament is heated to 2000 degrees Celsius. The electrons are emitted, and these emitted electrons are passing through the cathode. So this is cathode, not anode. You don't confuse with that. This is cathode, negative side. So when the electron beam are passing through the cathode, it will concentrated, and the anode that will accelerate. Anode have positive charge. Anode will accelerate the electrons, and the kinetic energy of the electron beam will be increasing when moving downward direction, and the deflecting coil or focusing coil that correctly position the electron beam over the workpiece where welding action is required. So this is the working of a electron beam welding process. Next one, advantage. The weld zone and heat effect zone are relatively small. In EBM, distortion effect is only very small. On steel plate 100 mm, thick weld can be made in one pass at a speed of 170 mm per minute with penetration. Speed of welding is high, no porosity and contamination. Disadvantage. Cost of equipment is high. Obstructed joints can't be welded because electron beam travel in straight line. Job is limited in size as per the work chamber dimension. So these are the disadvantages. Applications. Used for welding titanium, molybdenum and tungsten as structural component. It is commonly used for welding titanium, molybdenum, tungsten high cost materials. Okay, so this is all about electron beam welding process. So in this section, I have discussed about three type of welding process. First one, thermit welding process. Second one, friction welding process, and electron beam welding process. Okay,